Hi everyone, this is Sneha Nallapu from University of Central Missouri. Today I'll talk about building regulatory compliance systems by design, not as an afterthought. We will explore how architectural patterns like event sourcing, bitemporal data, graph lineage, CQRS, ABAC, and adaptive learning can turn compliance into an enabler instead of a burden. Let's go to our topic, the regulatory pressure landscape. The regulatory pressure landscape is evolving rapidly. Global institutions face risking complexity in areas like AML, data privacy, and risk management. Traditional compliance methods often come in late, creating bottleneck and always with penalties. We will look at why this reactive mindset is unsustainable. Okay. So if you look at the numbers, say it all. Escalating market growth in RegTech, billions of dollars in penalties, and huge manual overload. The cost of doing compliance is reactively massive. Instead of patching systems after every new rule, we need to architect them to anticipate regulation from like day one. So for that, the compliance by design is what we introduced. So as the name sets it all, it flips the mindset rather than bolting on controls later over. Compliance is basically it's like a design structural design principle. When compliance is built into our architecture, like security, scalability, performance, reduce risk, improve agility, and regular trust. In simple words, it's not a checklist anymore, it's a design strategy. Coming to the next one, let's see what are the patterns. So these are the three foundational and fundamental patterns. One is event sourcing, bitemporal data, and graph metadata. So event sourcing is this is for like immutable audit trails. Bitemporal data, this is for like time accuracy, and graph metadata is for traceability. Together, all these three fundamental patterns they make the systems naturally compliant, transparent, consistent, and audible. Next, event. Let's look into this like one by one. One is event sourcing. Event sourcing means every change is captured as an event, never overwritten. It's like keeping a diary instead of editing yesterday's entry. Technically, it's an append only log with replayable history and cryptographic integrity. For regulators, that means this is like full traceability and non repudiation. So the data is ever lost or ever hidden. There is no concept of that. So in this case, no data is lost at all. So let's go to the bitemporal data models. Bitemporal modeling tracks two timelines. One is transaction timeline, the other one is valid time. So what is transaction time? So transaction time is nothing but when it happened in real life. What is valid time? Valid time is nothing but when the system learned about it. This dual view allows reconstruction of reality at any point, even after corrections. It's vital for audit accuracy and regulatory trust. Let's go to our third pattern, which is graph based lineage. Compliance depends on knowing where data came from and how it changed. Graph based lineage uses nodes and edges to map data flow across microservices and systems. You can visually trace a report number all the way to its data source. This ensures transparency for auditors and easy impact analysis for engineers. Next is CQRS. CQRS is command query responsibility segregation. So this one separates write and read paths. The command side validates transactions, enforces compliance rules, while the query side is optimized for audits, monitoring, and reporting. So this separation improves scalability, performance. It is basically ideal for regulatory systems that need both accuracy and speed. Back. So ABAC is attribute-based access control, goes beyond user roles. It considers user attributes, data sensitivity, and context in real time. For example, an analyst in Europe can access Europe data under GDPR, while a contractor sees matched data. ABAC policies are declarative and fully auditable, making compliance dynamic and policy driven. Yep. Next, adaptive exceptional handling and reinforced hand learning. So, compliance exceptions happen, but what if systems could learn from them? So, this approach, this using reinforcement learning, we can detect exceptions, pick optimal responses, execute and improve over the time. The system evolves, reducing recurring complex issues and adapting to new regulations intelligently. That is what adaptive exception says. Coming to the next one, we talk about the architecture. So here is a view of implementation of effort across all the components which we discussed so far. So event sourcing and CQRS require significant work, while ACK and bitemporal models are lighter lifts. This helps to prioritize a phased adoption, like start small, prove the value, scale gradually. Next, let's talk about the business value proposition. So, the payoff is substantial. From reactive compliance to proactive assurance, from manual overhead to automated reporting, from risk management to competitive differentiation. So, embedding compliance boosts efficiency, trust, and agility. Next, let's talk about its implementation. This is a roadmap, a practical roadmap. First one is you assess all the gaps, map all the current obligations. Second one is design phase, where design around the core patterns. Third one is pilot implementation. We basically just pilot one domain to validate the results. Scale and optimize. So this is like wide and optimize. This approach reduces risk while building the internal capability. So, what are the key takeaways? Let's discuss. So, to summarize, compliance is not a burden, it's a structural principle. Architectural patterns like event sourcing, bitemporal models, graph lineage, CQRS, ABAC, adaptive RL makes compliance seamless. By designing with regulation in mind, we turn complex into a competitive advantage. Yeah, thank you for joining me. I hope this gave you some practical insights on building systems that are compliant by design, but not by chance. Feel free to connect on LinkedIn or please reach out after this session. I would love to continue the discussion. Thank you.